My name's Chris Bergevin. I'm relatively new here at York. From Maryland in the United States. Education-wise, I was an undergraduate at the University of Arizona, where I studied mathematics and physics. I went to graduate school at MIT in Boston, where I studied speech and hearing. And I did 2 postdocs. The first one was back at the University of Arizona in the mathematics department. And the second was at Columbia University in the Department of Otolaryngology and Head and Neck Surgery. So what inspired me to get in science? Well, that was twofold. First, there was this notion of critical thinking and this idea of trying to slowly peel apart layers by asking the right types of questions and really demanding a deeper understanding of things. And science really led me down that path. I've always had a really strong and deep interest in understanding signals in the world around us, whether it be how do we see what we see, or hear what we hear, or how does a cell phone work, or wireless, or whatnot. And so that really motivated getting involved in signals and systems and getting a deeper understanding for how we can understand the world around us and technology by that fashion. So basically, in a nutshell, research-wise, this is what I'm interested in, the ear, and understanding how we hear the world around us. And it's a really complex system, and it's challenging on a lot of different levels, and it integrates a lot of biology and physics and engineering and mathematics together into a really challenging problem. The ear itself is a very remarkable sensor. It's very selective, it's very sensitive, operates over a huge dynamic range. It even has a little amplification mechanism built into it, one that we still don't understand a whole heck of a lot about. So my approach is really to try and use physics to try and see how can we better understand the ear and how it works. And also conversely, can we use the ear in a way to better understand some new physics? For example, can the biology of hearing tell us something about coupled nonlinear oscillators and their dynamics? So a remarkable feature about the ear is that it not only detects sound, but it actually emits it as well. And you can measure these things using a sensitive microphone, which is placed in the ear canal. There's a lot we can learn from that, but it's a very challenging problem. Think in a rough analogy, imagine you're standing at the end of a very long hallway. And at the end of the hallway, around the corner, say, there's a closed room. And in that room, there's a cocktail party going on with people murmuring, having conversations. There's furniture, food, all that stuff. And you really want to know what's going on in there. But all you can do is stand at the end of the hallway where you're at and just try and listen carefully. There's not much you can do or see, so it's a very big challenge to figure out what's going on in that room down there. Maybe you can shout something down the hallway and see if there's any response coming back from that room. So that's analogous to how we use these emissions, these sounds coming from the ear, to try and understand the biology. And then also, in a broader sense, I have a very strong interest in just the biophysics underlying the senses in general. So how do we see? How do we hear? How do we taste? How do we smell? And how are all these various senses integrated together at a higher cognitive level?